Hello, everyone. My name is Nihar, and welcome to Learn and Grow. In this session, we will learn microservice architecture and its key characteristics. We will be covering what is monolith, what is microservice, key benefits, and the main challenges. With that, let's quickly start with monolith. Monolith is an architectural style which was used so far or still being used in most of the legacy application, where we handle multiple related tasks as a single unit. They bundled into a single deployable unit. We can deploy it together, the entire application, right, with all functionalities. Now, since they are bundled together, they have to be written in one technical language or one technical stack. There are many benefits around it, like inter-service communication is much easier, simple implementation, and then the database transaction is easy to maintain there. So basically, the transaction management is much easier. However, the problem starts when we start thinking about scaling. Since it's a single unit, it cannot scale individual component or individual APIs. If we have to scale, we have to scale everything or nothing. At the same time, if we have to make any changes, we have to change everything or nothing. Create lots of constraint around the flexibility and the agility. While we look into the alternate to all this kind of problem, we found microservice architecture. Now, with microservice architecture, it's another architectural style where we structure the application as a collection of modular service. Now, module is the key here because this is what we have seen as a problem statement in monolith, where over a period of time, we lose the modularity. But with microservice, we create the application with smaller module, or I would say a business module, right? And then the small unit is individual deployable unit. That's the key, because that's where we can achieve the scalability. There are lots of benefits around it. Let's start discussing about one after other. One of the key benefits is the modularization, because this is what we have seen in monolith as an issue. Modularization is a process where we decompose a large or complex application into domain or business module. Now, this is where we correlate business with the application. Modularity on the other side is very important for any system design, because that's where you know what module you have to put more emphasis, what we have to stretch, what we have to put security. So basically the design constraint also change from module to module. And since they are different module, we can change or we can adapt them without impacting other modules. So that means we will be more agile. And since the impact is low, the team or the development team would concentrate more on individual functionality rather all regression and other stuff. The next one is faster time to market. Since we are talking about smaller module, they can be worked in parallel, they can be deployed as a single unit, scalable, bringing agility, and they are easy to adapt DevOps. So with all of them, of course, we will get a better productivity and we will faster to market. The another one is scalability, possibly the very core concept behind microservice. Because we have seen earlier, if we have one particular service is heavily used and based on the access pattern, we would like to increase the scalability or increase the number of nodes, we cannot. We have to do everything or not. But in microservice, Think about this particular service where based on the access pattern, it has been used heavily. I can deploy in 5 different nodes in a horizontal cluster. Likewise, the 4, 2, 3. So every module can be scaled separately without impacting other modules. Now that's the key benefit we get with scalability. Since we talk about parallel development, they are very easy and suitable for DevOps. We can implement continuous integration, we can implement continuous delivery, we get all kind of automation benefit out of it. We talk about CI/CD, we talk about DevOps, microservice. They are microservices are nothing but smaller deployable unit. Now, if they are really small, they just serve a very atomic problem statement. Do we really need a large VM or a large individual system? If not, why can't we go with container? And that's one of the reasons why container management systems are increasingly popular at this moment. Now, with all of them, we are heading toward cloud native. Another advantage what we have seen is with the smaller module, smaller team, they concentrate on individual problem statement. Now that problem statement can be solved with an individual language. I would choose that one. And in that way, I become more technology agnostic. And smaller team, there's a diverse team. They have their own expertise and they expertise, right? So these are like few of the key benefits we get with microservices. However, there are there are many challenges around microservices, and primarily because of distributed programming. We talk about lots of benefits on microservices. However, there are many challenges as well. Let's discuss about some of the challenges. Service discovery is one of the main challenge, because we are talking about so many microservices. They talk to each other. How one service can find another service where every service are part of the cluster, right? How I will know which particular node the service has been deployed. Now, with this, we need to understand the registry model, right? So there are certain tools like Eureka, Istio, API Gateway, and other. They give a registry mechanism where every microservice will register themselves and the client would look into the registry and find out the endpoint. The next challenge is the load balancing. We talk about multiple node per application or per microservice. Now, if they're horizontally clustered, I need to do a load balancing. Now, on that scenario, I need to be careful about how shall I do the load balancing? Shall I do the load balancing on the client side or shall I do it on the server side, right? Jar like ribbon are more useful when we do a client side load balancing. F5 or API gateway are more on the server side load balancing, right? There are many other available in the market from the public cloud service, right? The next one is the fault tolerance. We're talking about so many microservices. Since more and more components are building this application, enterprise application, if one service fails, it will completely fall the entire ecosystem. How we can avoid that, right? We need a fault tolerant, a circuit breaker kind of a pattern, right? We have Hystrix, resilience 4J that will define how many retry mechanism. There is a alternate URL, error message, cooling period. There are many other concept comes into picture, but end of the day, we make it more resilient. Another key one is the distributed tracing. We are talking about so many microservices. Do we really know what's going on in the microservice? Who is accessing it? Where the issue is? Since we are talking about individual microservice as an individual deployable unit, they generate log locally. So it's very hard to find out real traceability. And that's where the distributed tracing comes into picture. There are certain tools. There are certain tools like Jaeger, Jipkin, Sleuth, Humio, and they help us to build an enterprise level distributed tracing, which means we'll have a span ID, we'll have a trace ID, or trace ID and span ID, and they will capture all the local log and put it in a centralized place so that we can have a better visibility. Um, Moving from here, security is another key challenges we have seen, because we are talking about so many microservices. They talk to each other. We need to ensure that it has to be restricted, and only the authorized service can access the microservice. How we'll do that, right? We can do it through data security, the access pattern, uh, from authentication, OAuth or ping token, or we can secure it through TLS. So security is another key feature, but there are many tools and many mechanisms where we can secure the microservice. The next one is the config management, scaling up config management. So again, right, we are talking about many microservices. There are certain local configuration, there are certain global configuration. Now, if they are local and global, and if we have to make changes, how many places we go and make changes? Rather, we will put a configuration database and everybody would read the database and get the configuration information. Now, in that way, the service can be scalable, and eventually we get our scaled config management service. Next one is another key challenges we have seen with so many microservices, how they talk to each other. Are they talking to each other through network level, or they're talking application level, or each microservice run its own process, right? So that means they have to send the serialized data. So how they really interact with each other? Are they using HTTP, gRPC, or async communication? So there are certain tools available which helps us to do that. For example, Fin client, REST template, web client. So there are multiple ways they talk to each other, right? We can have an event bus, asynchronous communication versus synchronous communication. So there are many ways we can deal with the different type of interaction issue. The next challenge is API gateway. API gateways serve as a reverse proxy to all API calls. Now, it forwards the call to respective microservices, and from there it goes back. Now, since we are talking about a gatekeeper, we put all the cross-cutting concern in the gateway. And that's where API gateway comes handy, where we have tools like Spring Cloud Gateway, Apigee, and others, right? They help us to implement the load balancing part, security, TLS termination, rate limiting, and many more. We have seen the monolith world, we have seen the microservice world, how microservices evolving, and the key benefits like modularization, scalability, cloud native, technology agnostic, and many challenges like service discovery, load balancing, fault tolerance, distributed tracing, security, interaction between them, and many other. To summarize, microservice is a great architectural style for distributed and cloud native application. Thank you for watching the session and hope you learned basic information about microservices. I'll see you in the next session. Bye-bye.